Okay, so recording has started, right? Right, so we've gone through quite a bit with problem solving. I think that we've done the problem solving process. We've spoke about algorithms. We haven't really talked about problem solving methods in any great detail. That's a bit of a theory point that we'll come back to. We did take a look at the stages in the problem solving process, took a look at the properties of algorithms. I think that to a certain extent, we can express algorithms as narrative flowchart and pseudocode. These things, as we progress, we will continue to work on it, getting better and better. We've spoken about input and output statements in pseudocode. We've spoken about control structures. So we've done sequence selection and iteration. We've spoken about the different types of iteration. We've taken a look at the term sentinel control. I spoke about that as a sentinel value before. In the while loop, that value that is being watched to dictate when looping should stop. Okay, we've done a couple algorithms from problems. I mean, you have actively, you have, no problem. Actively, you have an assignment that needs to be done. Okay, I think that assignment is due tomorrow, and the lock-off date for it is, I think, about Sunday or so. So keep on top of your deadlines, please. We've seen that we can develop algorithms from cases. We've looked at some algorithms. We've looked at some algorithms in terms of being able to identify the error in them and fix the error, etc. So we've also used trace tables to be able to test for correctness. Okay, in terms of doing a test plan will come a little later down in the whole scheme of things. So we've done essentially most of module 2. We just have to practice. Okay, we just have some practice to be done for most of module 2. And I think that when it comes to algorithms and algorithm writing, etc., we'll be fine. So I think that we've progressed well. What do you think? You all feel a little moving along well enough as well?
To be honest, I kind of feeling like like I a little bit behind at the class, just a little bit. Uh, but I'll see what I could do about that, I guess.
All right. You feel as though we should pause and practice a little bit more as to where we are, or you know exactly what areas you feel you need a little work with?
Yeah, I guess most of the latter because I mean, I'm not really speaking for the whole, I can't really speak for the whole class because, you know, I feel like I'm at a disadvantage because of the fact that I missed our last face-to-face class as well. So,
So the last
I really,
face-to-face class was recorded, There's a YouTube playlist with all of the recordings of the class.
all right, well, I guess I'll check that out then.
I believe it
Well,
was recorded, yeah, and added.
all right,
I guess somebody could verify that for me. Okay, so I will also, maybe I didn't post it in the class in the chat in the stream, but I will post the link to the YouTube playlist so that in the event that you have to go back to any class, in the event that we have to go back to any class, we will be able to, we'll be able to catch up quickly. Okay. Anybody else want to share? Want to say where they are, how they feel? I given other opportunities there, people. I'm giving you all opportunities to say. Yes.
Yeah, my computer lagging right now. Sorry about that. Well, I feel like if a little more practice is needed in the mod. Well, like if your brain melting on questions is normal, okay. Well.
Yeah. At this point, it is normal for that to happen.
Okay.
Honestly, you know, sometimes your brain should be leaking out your ears or something. So after you finish, right?
Yes.
As long as the top of your head don't catch a fire. If that happens, then we in problems.
Well, so I had the same issue as Jonathan because the day that you do while loops, I wasn't there. So I was piecing it together from the rest of the classes he was doing NASA. And I look at number 4 in the thing again. Well, the homework we have due for tomorrow, and I was like, what? I look at that and I had no clue what to do. Right? Like it's still blank, but I try nothing. And since you now tell me the YouTube thing now, I'll check it out. But
all right, so I have posted it on the stream. Okay, so that YouTube list is where it should contain all of the sessions that we had. So that should be you know, at least something there. Okay. All right, I think maybe the YouTube list, the last thing it has is it's up to date as far as I see. All right. It's up to date as far as I see. The 16th. Maybe I'll check if we have any video from it. But you know, if not, I could recap today, and I could also go through the assignment and let's see if we can maybe I might be able to assist you all with one or two, because I was looking at it. I mean, it's not too bad, but you know, I could see where, as you're now getting used to it, as you're now getting used to it.
To think out the box,
Yes, it does. In some
Excuse me, I wasn't getting any problems with it until question 4, I believe. The same one that I believe Keon was talking about, where he couldn't figure it out. But that's not because I like how do you say? That's not because I like the structure of it and that I can't understand the question. Like I know how to solve it. It's just that I can't, like the math bit, I think it's off. Because I was checking it and
let's take a look at it and see now.
yes, because I don't know if it was me that wasn't like understanding the question, or if it was the question that was just a little off.
Wait, which question was 4? Because honestly, I can't remember.
I think that's the one with the money.
With the money?
That's the one with the paper.
Oh, I did that one. Honestly, sir, I would say everything comfortable until the results of the homework come in. Because I sat down and it took me like, I want to say 20 to half an hour to figure out how I did that particular question. But I don't think the math's off. It's kind of like how we did the one with the coins, just on crack. That's the best way I can explain. Like, if you remember the one we did with the coins, like is that just on crack? But it is possible. I don't think the math's wrong. It's more the logic you have to use to craft the algorithm. It just like tedious. That's the best way I can describe it. But to me it was doable. And well, if it come back and it wrong, well, it wasn't doable. But as it stands now, mentally, I think it was doable. I think all the questions was doable. It was just like, it was difficult in the sense that you couldn't think of it straightforward. And I think I have that problem. I don't know if anybody else in the class had that problem. But like when it comes to analyzing stuff, you just look at it head on. And well, in life, I would look at the bigger picture. But I think within this now, I think something that we have to develop is like having the ability not just to look at what we have, but what we could have and how to interpret it. I think that's the biggest thing. But one of my biggest issues right now.
Okay. So right now, you think that you're in a process where the way you approach problem solving is being changed, so you have a bit of dissonance going on inside of your brain then?
Yeah, like to me, I find currently my problem solving ability is great in my opinion, but I think this just going and elevate it even more. Like
Okay.
to consider stuff that I would normally consider, like stuff that you would think, oh well, that obvious. Like stop thinking like that and actually dive deeper into what I believe is obvious.
Okay. All right. Well, that is the journey, yeah. So, I mean, as long as you're flexible and you're willing to see that there are different or there are alternative ways, some of which might be better, some of which are not, then that's fine there. Okay, so let's take a look at question 4 now. We wouldn't I just want to clarify because I don't want anybody feeling like if we didn't give a fair chance for everyone to attempt a solution. Okay?
No, so I think it's just without question. I just think is well for me. I just think is the interpretation because I don't think I understand what the question trying to say.
Well, right. So we will get into that. We're not writing any algorithms or anything so. Okay, we just want to write we just want to take a look at, well, what we could do in terms of trying to solve it. Okay. All right. So I'm going to switch my screen to open board. All right. So we have that a customer needs a specific amount of paper. The charges on the paper are 10 cents for single sheets, 55 for amounts and multiples of 100 sheets, 4 cents in multiples of 500 sheets, and 3 cents in multiples of 1,000 sheets. So basically what we're saying here is that if you are paying for one sheet, you're going to pay 10 cents. All right? If it is that you are buying 100 sheets, okay, 100 sheets, you're going to pay a price of $5.50. So this is per sheet here. So this will then mean that I pay 0.055 per sheet. Understood? So if I wanted a ream of 500 sheets, I will have to pay 0.04 by 500 is, let me just calculate that quickly. All right. 4 by...
Yes, sir.
Hmm?
This what you're doing here. This was our assignment we had. Apart from the pseudocode and the date verifier.
Apart from the what?
The pseudocode saying that due tomorrow and then the date verifier thing. Is this a separate assignment from both of those?
This isn't this in the pseudocode assignment? This is number 4.
Yeah, just say that.
Yes, that number.
All right. Cool.
Who asked that? This is one of the questions in the assignment.
So I
caught red-handed.
So I see the first question, so it's just the normal output and then the logic stuff, and I didn't see anything after that.
No, the question has the assignment has 8 questions in it.
All right.
Yeah.
Thanks, sir.
Well, it's a good thing, right? It's a very good thing. All right, so if I'm buying 500 sheets, then I would pay $20, which would mean that I'm paying 4 cents per sheet. And of course, if I'm buying 1,000 sheets, I will pay $30 for 1,000 sheets, which would mean that I'm paying 3 cents per sheet. Is this clarifying anything for you all as we talk about it?
Yes,
Not yet, sir.
Yes, that is
Sorry.
how I
Yeah,
interpret the question.
So,
I guess.
so just ask, so just to make sure for number, I now realize the number 3 to 4 here. Sorry, 3 to 8.
Number
So
what?
I now realizing the rest I didn't do. So it's just the output we're supposed to be doing, right? It's just that's what it
No,
is?
for number 3 onwards,
Yeah,
you have to write
the
pseudocode
pseudocode. Oh, I understand.
to work out the solutions.
Oh, okay. No
So
problem.
for 1 and 2, you have to give the result. You're just giving an answer. True, false, a number, whatever it is. For number 3 to 8, you have to provide the pseudocode algorithm that would allow for this problem to work.
Oh, all right. Thanks, sir.
Okay?
Yes, sir.
Right. So essentially, what this question is asking is, at what point does it become cheaper? At what point does it become cheaper to buy the higher ream? Okay, because in the example for 380, it wouldn't make sense to buy 4 reams of 100 because you'll end up paying $22. Okay, so I need 380 sheets. If it is that I buy them by 100, I will have to buy 4 by 100. Because I can't buy, unless I'm buying, 3 by 100 and then 80 by single sheets, etc. Right? And if I buy an 80 by single sheet, that will still be a lot of money. Okay? So if I'm buying 380 sheets, essentially what I'm looking at is moving up to the next 100. So I'm going to buy 4 by 100, which would be $22. But then if I buy 500 sheets, I get more paper, I cover the 380, and it'll be $20. So what I'm doing is they're asking me to write an algorithm to figure out the ranges at which it becomes cheaper to buy the next increment set of sheet. So how many single sheets would I need to buy as single sheets before it becomes more expensive to buy the 100 sheets? Because if a ream of 100 sheets is $5.50, right, and a single sheet is 10 cents per sheet, once I buy more than what amount of sheets should it be more economically feasible? If I need 80 sheets, then what should I buy? Hello?
Yeah, 100 real, right? 100 sheet real, right?
What?
100 sheet real, say.
Right, because then it's cheaper because 80 sheets at the single sheet price will come up to probably about $8.
See, I think set other questions.
Yeah,
Go
so
ahead.
I was just gonna say that this clears up a lot because I was looking at 380 and Yes, sir. Just clear it up a lot. I don't understand what the question asking.
Okay.
Yes, sir.
So I need not do any more, right?
No, sir. I get that.
All right. Anybody else? Clement, you have a statement to me?
Yeah, this is the easy part here, say. The hard part is finding all the say I thinking it's only 8 marks here, but the amount of things you had to put in this code, I feel it should be weird for the whole entire thing, sir. I just want to know, sir, if the algorithm gonna be real long or it have a short way to do everything.
Do not overthink the algorithm. I'm not looking for a bang for your buck algorithm. We just want, I'm not asking for cheapest overall sheet price or whatever. We're just looking at having a cutoff for when does it become better to buy the next tier of sheets. That's all.
So basically,
Don't go back and decide, okay, well, it's cheaper to divide 100 by 5.5 and all of that. No.
So it's basically you're looking at the sheet package before and the sheet package after. Those are the only two you're comparing, right?
Yes.
Oh, okay.
Right.
Okay. Thank you very much.
Don't overcomplicate it. Not at this point. The time will come where we can overcomplicate some matters, but for now, let's just keep it, as simple as possible.
So you could try 740, sir.
740?
Yeah, as the example.
Okay, let's take a look at 740 sheets. Okay. And maybe I might have to say, let's cap it at 500, right? So is it better for 740? Okay. Is it better at 740 to buy 2 by 500, or is it better to buy, sorry, not 2 by 500. We have thousands, right? 1 by 1,000, or what is it? 500 and hundreds. Well, what is for 740?
So you could do 1 500 and two 100s.
No, you need 3 by 100.
I need 300, yeah.
Right? Which would make this 550 by 3. And 1 by 500 is $20, right? But then 1 by 1,000 is off the bat $30. So what do we see here?
At 1,000 is the better buy.
Right, 1,000 is the better buy. What I think like a troublesome one might be to look at something like 12, 30 sheets. If you have 12, 30 sheets. 12, 30. 90 sheets. Is it better in this case to buy what?
1,000.
1,000?
Yeah, this is like and you gotta work out for all, right? So, because you don't know which value they input in. You gotta work out for all possibilities. And so,
Right, but I would do 1,000 sheets, but what about even 1,000 and 500?
Yeah, you can do that too, so.
I was thinking at 1,000 and 500 versus 1,000 and 100. Right? And then for the 1,000 you have 30 and 20, this is $50. And for the 1,000 and the 100, this is $5.50, $5.50 and 30. Which one coming out better? This is $41. So in this case, it's this. I would suggest, you see this basic structure here? this basic structure here, it could be looped there. It could be looped. Okay? And that will make working out those larger type values much easier. Because once, let's say for instance, and I feel like I'm gonna give away the answer saying this. Anybody have a problem with that?
So we already this deep, say.
Yes, no. So don't say it. Please don't say it.
Say it.
Don't
Don't
say
say the answer.
Yes, don't say it.
Say we already this deep.
Say the answer.
I meant say we already in so deep, so I might as well go to the answer. All right, let me ask for a show of hands. Anybody want me move forward? Who want me move forward? Let me see your hands. Out of the 22 of us present, I only see one hand so far, 2 hands. 3, don't put your hand down yet, eh?
Say when you see move down, say move on, say. You mean
move forward as in go deeper. Give you all another little hint.
Swim deeper. Okay, cool, say. All right.
Okay, I feel the majority have it here. I feel the majority have it here with Clement celebrating. All right. Okay. So what I would suggest you do in this instance is that, let's say for instance, we have that 1190 that we're supposed to look at. When you work out, okay, the first biggest amount that we could take is that 1,000 out of there, right? If I know how much thousands I get, I could say 1190 mod 1,000 is going to give me 190. How much thousands do I have, right? If I say 1190 as an integer divided by 1,000, I'll get 1. So this tells me how much of the thousands that I need. Now I'm left with this 190. I could run back and it will do the comparison now based upon like if my original value was 190, because I could say 1190 minus 190 is going to be 190. So does it now make more sense to buy 2 by 100 or 1 500? And once I work out that, I add it to the amount that I had here. And that's all I could say in terms of coming to an answer.
Well, I was on the right track, so.
What's that?
I was on the right track.
Okay. All right. And I will be honest with you all, I wasn't even looking at any amounts over 500 sheets of paper, you know. Really and true. That's why I say don't think too much about it. All right. But seeing that I'm going all the way, let's go all the way with answering.
Okay, sir.
All right. So any other question you all want clarification on? I know, I think Real was asking me for clarification on a question with a list or something, so.
No, so not me.
Was it Real? No, it was Hansen.
Yes, sir, that was me.
Okay. Hansen, yeah, which question was it that you said had a list or something, so? And
it was question 8, sir.
Question 8, with the counselor of a camp. So the number of people attending a camp could vary from 50 to 100. So we want to store a list. I know that you all in a way kind of thinking in terms of wanting to store all the values in a list. But let's say for instance, let's write an algorithm, right? Let's write an algorithm right now, pseudocode algorithm that will accept I don't want to have the same average age, who the oldest and the youngest are. Okay. I will do part of this question. All right, so let's say for instance, we want to we want to accept a let's do the Happy School Club promotion where persons must guess the amount of jelly beans in a can. The first value placed into the algorithm is the amount of jelly beans in the can or jar, sorry, not a can. Who keeps jelly beans in a can? All right. The first value placed is the amount of jelly beans in the jar, and all other values from students are guesses for the amount of jelly beans. The first person to guess the correct answer wins, but if no one guesses the correct answer, then if no one guesses the correct answer, then the person who is closest is the winner. This is very similar to that question. Yes? Everybody understand what this question is asking? I see a couple hands up still. These hands are up from when I asked for hands to be up, or is it that you all have questions?
I have a question.
Yes, we are.
So you say if no one guesses, how many times a person could enter to guess?
One. Let's put that down. Each person, right, gets one guess, and their number, right, starting with person number 1 is recorded. If they are the winner, or if they are the closest. Okay. There are no more than. All right, let me put it, because I want to put this like in the last question, even though I feel like I shouldn't, you know. I feel like I should. I feel like I'll let you all figure that one out. Okay. So the guessing stops when a negative value is entered as a guess. Does everyone understand the question here?
Yes.
Yeah, it seems straightforward enough, right? So let me do it. I'm going to, on a piece of paper home here, right? Everybody seeing the piece of paper I have in my hand. I'm going to write down the number that I have, okay, on this piece of paper, because of course you're guessing. So I'm going to tell you all that the number is between 1 and 100. Okay, we're doing the exercise right now. So I have the mystery number, and as it goes right now, I don't know who is the closest person to getting this answer. All right. So the winner is currently unknown. But okay, who is the first person that's making a guess? I'm telling you all that the number is between 1 and 100. Who is the first person that is making a guess? First person to guess. Anybody? Work with me here, people.
I will guess.
Thank you.
Omar,
what's your guess? You're number 1.
42.
Okay. So far, Omar is the winner. Why is Omar the winner right now?
Because it have no other guesses.
Because it have no other guesses. So keep that in mind. The first person to guess by default is closer to my number than Omar. So closer to my number than all the other people who don't exist, and that is Omar. But if somebody else guesses now, could I get another volunteer?
Yes, sir.
Omar, yes, sir.
I just need a number
47.
between 1 and 100. Huh?
47.
Who is that?
Gerald.
Yeah, Gerald had luck. Omar's still in the running.
Hey.
So what was Omar guess?
No, you had to pay attention. So.
Well, my guess is 21.
Okay, who is this?
It's Elon, sir.
Elon is closest right now. Okay. So right now, Elon is in the running to be the winner. Anybody?
So my guess is.
Anybody else want to guess?
My guess is 26.
Because you're doing this in person, you all getting close. You all getting ideas that you all you all getting ideas that yeah, you're kind of slimming down the number, but all of this is going to be unknown to the person who running the algorithm. So go on. Who's next?
So my guess is 26.
26. The fourth person is very close, right? And I'm not taking any more winners. So the next, I put in -5 to stop taking in winners. The winner is the fourth person who guessed. My number was actually 27. Okay.
Yeah,
so the number was 27. Huh?
I find this process now. We can say I say 27 and.
Who said 20? I thought you said 47.
So he ain't saying nothing.
Trying to mess up my class processes and stuff like that. All right. John was totally off with our number he typed there. Right?
So I was just saying, say 26.
John, you say person who say 26?
Yeah.
All right, good. So John, then you're a fraud. Then number 3 win because now I tell you can't enter twice. All right. Okay, so what did we know? What did we learn from this process? And the thing is, when making algorithms, you have to, it seems like a waste of time sometimes, but you have to go through the process manually and think to yourself, what steps did we do? What steps did we do towards getting the final number, right? What steps did we do? I kind of showed you all piece of the steps. Again, we're looking at solving this problem, this particular problem, because this problem is similar to number 8.
Basically, what you did say is what you made a loop say, right?
Right.
But inside that loop, what you did was you took in the number that was closest to the guess number or the winning number, and you store that in a variable in your brain, say, right? So after, as you go along, you check to see if the number coming in that same loop is closer to the number than before. And if it's not, you just skip over that part of the if statement now. If it's checking, and you just add to the counter, and then you go around again and around again until you add a -5, which it can be like a while loop in your brain. Yeah.
Correct. So here's what, right? Here's what. Let's go through this process visibly. And the thing is, we don't need any sort of array, or we don't need to store more than one variable that is a guess at a time. Okay? Because what I have here is I have the answer, right? So we have the number of beans. And let's say, for instance, the number of beans in the jar is 442. We have a variable called current guess. We have a variable called current number, and this will start at 1. We'll have a variable called closest guess, and we'll have a variable called closest number. And what's the purpose of closest guess and closest number? Closest number will also start at 1. Because the first person who have the current guess will be the closest guess. So let's say, for instance, my values coming in at me. The first person guessed that we had 352. The current guess is 352. What is the closest guess right now? 352. But what if the second person guessed 400? Okay, we look at 352 and 442, right? We say what? There's a difference of what? 90 between them. And now we look at 400 and 442, and we say there's a difference of 42 between them. So as it goes, the closest guess now becomes, and this of course, the 400 becomes now the current guess. Okay, so 400 is now the current guess, which is guess number 2. We look at the known value for the closest guess, and we say, is there less space between this to this as there is between this and that? And if it is true, then we say, okay, store current guess inside of the variable closest guess and store current number inside of the variable closest number. So now the closest guess was 400. Let's say the third person decided to guess 702. So number 3 becomes 702. Is this person closer than the closest guess?
No, sir.
No, they're not. So what do? We don't change closest guess, right? Let's say somebody take 391 as the next guess. 391 as the fourth guess. Again, not close at all, not closer than the closest guess. Let's say that somebody gets 430. All right, this is number 5. So number 5 was 430. Now we look, we say, okay, what's the difference between 430 and 442? That's 12. Is it closer than 42, which is, yeah? So then now my current guess becomes the closest guess. How am I to write this as an algorithm? So closest guess would be number 5. And then I decide to say, okay, well, the next person, current guess for number 6 would have been -9. we decide to stop there. How am I writing this as an algorithm? We kind of just went through the steps. Everybody understand where we come from there? You see, going through it kind of helps us identify even what variables we need, what processing we have to do, and when should I output something or when should I not output something? When should I process something and when should I not process something? You all follow me?
Yes, sir.
Okay. How many, let me ask a question, show of hands. How many of you all take that approach when you all solving your algorithms? Or you all just try and keep it all in your brain? Okay, so I see one hand up.
It just take too long to raise my answer, so I just take that approach.
All right. I mean, it's literally one more click than it would have been to turn on the microphone.
So my computer has been lagging so much, so you don't know, like, I just shut down my computer, so.
Hey man, if the pain is real. All right. All right, so let's see if we could write some statements for this and maybe even implement this in C. Okay?
I have a question.
What's that?
I have a question.
Yes.
So what if we, after we write our pseudocode, so what if we put it into C so we could get extra marks?
No.
Come on.
It'll be good. It'll be good practice. It's good practice. I would encourage you to put it into C.
So
right?
Then sir, you gonna need a while loop and a for loop to do this?
You'll need a while loop. You just I don't think you'll need a for loop.
No,
or you just put the count in the while.
Yeah, the count will go into the while, yes. Okay, so let's start with, okay, I'm gonna remove, well, I'll put this on the side, okay? With this whiteboard, at least you don't have to erase anything. So let's take a look at the solution. You like typing in blue today, all right? A nice Manchester City type blue.
So you go and work out this question, say, but you're not going to work out number 4, say.
I'm not going to work out number. Yeah, but this is this not a question not on the exam. Hold on, my
Okay.
Right. Hold on, my board crashed just now. Right. I hope that right. Everything was saved, but all right. So we do know that we need at least these variables here. So let's work out. Let's initialize those variables, right? We identify that we have so all of these are integers. I color a little bright. We'll go ahead green. Okay. We have integer. And we have the number of beans. We have the current guess. We have the current number, which starts off at 1. Okay. So we have the number of beans, the current guess, the current number. And we have the closest guess. Number. And so the first thing that we have to do is what? Remember, you're walking me through this. What did we do? What was the first thing that we had to do? The first thing that we had to do was that we
say
put the current number as 1.
The?
You put the current number as 1, sir.
Yeah, the current number is 1 and the closest number is 1. I initialized that up here. So the first thing that we had to do, what does the algorithm say? The first value placed into the algorithm is the
number of beans in the jar.
Right, so we say print, enter the amount of beans. And then we say input num underscore beans. Where do we go from here? From here, we have to start doing an algorithm. We're doing an algorithm. And what does this algorithm require?
A looping structure.
A looping structure. So what type of loop would be best to use here?
You had to use a little while. So.
Okay, so let's use a while. But for our while loop to work, what do we have to, what is the, oh my gosh, what you call
Criteria.
it? The criteria. Thank you for the word. That is going to govern my while loop. While what? I'm going according to what I say here. While what? Let me call some names. Find people quiet. Okay. Jeremy.
Yes, sir. Yes, sir.
Right. While what? What is my criteria for my while loop?
So I'm thinking.
Thinking. All right. Who is the person who suggests the while loop? That was Jarrell.
Yes, so we inside.
So Jarrell, what we putting inside the while loop?
Alright. We gotta put while current. No. Yeah. While current beans is not equal to NASA.
Current, yes.
Backspace
Is
that's
not
forget
equal.
it.
Is what?
Forget it.
What do you mean forget? You was going well.
While current G is not equal to amount of beans. I don't know.
All right. Now you kind of. I thought you was
I'm
going in a direction and you turned the direction. That's all right. The first thing that we would have to do so that we could know how to loop. What is the criteria to stop looping?
When a negative number is entered.
Okay, so how would I know if a negative number is entered?
One set less than 0.
So then my criteria would be while current G is
More than 0.
Well, right, let's say greater than or equal to 0. Yeah. But what is the problem with this, how I have it written here? What is the value inside a current G currently?
Nothing.
It's not nothing. It must have something.
1.
Current G is not 1. Current G is currently undefined. It could be anything at this point because we never set a particular value to it. You all follow me?
Yes.
So what should have been done before this current G was this criteria was before this criteria was what you call it was identified. We need to have a value inside a current G.
I can make a suggestion.
I'm looking forward to this suggestion, Real.
Instead of using a while loop, we could use a do while loop.
A do while loop is probably best here, yes.
Yes, sir.
Okay, because at the very least, you're going to have to take a guess from the person at least once. So we could say do what? Do what? So okay, printf or print, sorry. Enter a guess for the amount of beans. And then we could say input what? Input current underscore guess. So the first print was to enter the amount of beans, and then we store that amount of beans. So if it is 400 and something beans, we store it inside there. The second thing that we ask, and this will be all subsequent input, enter a guess for the amount of beans. And we could say input current guess. Okay, input current guess. And what do we have to do now? What if this current guess is a negative number? What do we do? Do we still want to compare it against the amount of beans and all of that?
Nah, I go printers are invalid.
Okay, so I'm going to change this to no here, 0 here, just, and we'll see why.
You could use an if statement, sir.
Right? Right, so we could say if what? If
current.
If what? Is?
If current G is more than 0.
Right, if current G is more than 0, what
Print
do we
valid.
do?
Print valid guess. Print valid guess.
Okay, well, we know it's a valid guess, but we have some stuff to do. If it is greater than 0, then it means that we want to keep it as a reasonable guess. So let's say car underscore n is equal to car underscore n plus 1. Okay? Or before we even do that, we have to know whether or not this is the first guess or if this is not the first guess. Because in the case of the first guess, what do we do?
We have to store it in close guess, I believe.
Right. The first guess is always a right guess. So how do we do that? How do we know if this is the first guess? We'll know that this is the first guess by current n being equal to 0. Right? Current n being equal to 0. So if I say if car underscore n is equal to 0, then what do? We say close underscore g is equal to car underscore g, right? We could increment the current number, curr underscore n is equal to curr underscore n plus 1. And then we could also do what? We could say that close num is equal to 1, which it starts off at initially anyway. So, you know, it makes no difference there. And we could end if. Not end if, but we could then say else. What does this else mean? So we have some code form in here, and maybe I should write in a different number, right? So we could say, what have we done so far? I'm going to kind of annotate this. Okay? I'm going to annotate it. So ask for the number of beans. Ask for the number of beans. I'm going to annotate it in a kind of pinkish color or something. So, right? And then we want to say, get the guess from the user. Get the guess from the user. And then we say here, if this guess was valid, I.E more than 0. If the guess was valid, then what do we do? If the guess was valid, that is, the guess was more than 0, the first thing that we do is check to see if it was the first, check to see if this was the first ever guess. So if it is the first guess, set the current number to 1. Set the current number to 1 and set the closest guess. Set the closest guess to the current guess. Does this clear up anybody who feels like it wasn't following where we were at this point? Does it clear up for anybody? Only quiet, so like they want a break or something. So.
That's it. That means I was following.
All right. So we're going forward. We're going forward, right? Because we don't have much time again.
So, quick question. Why we need to check if it was the first ever guess?
Because remember, we said that for the first ever guess, we must record that as the closest guess.
Oh, okay.
Yeah. So if the guess was, so this else here is for this if here. Okay. So this else means if this is not the first guess, else if this is not the first guess, then what do we do? If this is not the first guess, what do we do? What do we do if it's not the first guess?
Yeah, I compare it to the number.
Right, you have to compare it to see if it's closer than the known closest guess. Okay? So if it's not the first guess, we must compare it. We must compare this guess with the known, or let me say against the known closest, to see if it is closer. So you have to compare this guess against the known closest to see if this is closer. Okay, so how do we do that? We would say if what? If, so we have an if statement. If what? If guess, if the current guess, right, sorry, if the number of beans minus the current guess is smaller than the number of beans minus the closest guess. The number of beans minus the current guess is smaller than the number of beans minus the closest guess, then what do we do? this means that we are, this means that
current guesses.
we have a new closest number. Yeah? So we have close underscore G is equal to current underscore G. And we also say close underscore close underscore help me out here. Num is equal to current underscore num. Okay, one thing that I have to do here is to ensure that I increment the car underscore num here is equal to car underscore num plus 1. I place that in a bad position. Maybe in the future, maybe we could move that around later on, but we'll see where we could put that. Changing colors in this thing is going to be difficult once I go down to the bottom and you know, once I can't reach up to the top in this thing. Right. Well, we'll solve that problem when we get there. All right. So you all understand what happens here. So if this is the first ever guess, if it's the first guess, we set the current number to 1. Okay, we set the current number to 1. We could actually just put 1 here because it's the first guess. And we say, set the closest guess to the current guess. Okay? But if it is not the first guess, we have to make sure, that we know that for a fact that this number, that this number is closer to the number of beans than the closest known number of beans. And if it is, then we set those values there. Anybody have a problem so far?
Yeah, I have a problem, sir, with the last if statement you make, right? Well, I think that only accounting for if the current guess is like lower but closer. It not counting if it's higher or closer. You understand what I'm saying, sir?
Well, true. I was thinking close without going over. All right. But we could work with that now. If you want, you can modify it for higher and closer as well.
Oh, okay.
Huh?
So
Yeah,
can't you just put that what there?
Repeat?
Sir, ask it, could you just put an or there, sir?
What there?
An or statement.
Where?
So
Here?
Yes, sir.
Yeah, you could do that. You could do that. You could do that. What do you mean for like the higher going over?
Yes, sir, for the higher going over.
Yeah. You'll put an or if it is closer with the higher going over. But I'm leaving it closer with the lower going over because I try to keep this simple. Okay, so it's as close as possible without going over, let's say. All right. But you could modify it and you could do that. I encourage you to do that in your free time. So let's see. If it is that if I could just copy this, right? If the number is closer without going over the number of beans, then what did we want to do here? We give the current info as the closest info. Okay? And then we could see an end if here, end if, and you have to put a end if here, end if, right? So if it is that this was not the first guess and it was closer, then store that number as the closest. If it wasn't closer, then you don't have to do anything. Okay? And then you come out and we end if, and end if. Everybody is fine here with this so far? Once we hit this while, right, while current G is greater than or equal to 0 or greater than 0, whichever one you want, whichever one you want as your criteria for thing, if you don't want anybody ending up with 0. But what if it is that when we entered here, right, when we entered the first guess, what if the first guess was a negative value? What happens in this instance? What if the first guess was a negative value?
The program will just stop running.
Huh?
Will it just stop running?
It'll stop running, but should it display some information to the user?
Yes, sir, at the end of the while, at the end of the do while.
Right. So what should be displayed after the end of the do while? In both the instances of when there are values and when there aren't values. Okay? Say here, if what? If car underscore n is equal to 0, then we could say down here, print there were no valid guesses to no valid guesses in the contest. You could print the winner is close underscore G with a guess of the winner is close underscore G with a guess of close underscore N. Everybody understand how I get this? And this is the algorithm here. This is our algorithm here. So let's take it in. All right. We said that the first thing is that we ask for the number of the beans. We got a guess from the user. If the guess was valid, once the guess is valid, then we check to see if this is the first ever guess. If it is the first ever guess, we set the current number to 1, and then we set the closest guess to the current guess. So we set the closest guess to the current guess. So it means that the first valid guess is always taken. If this is not the first guess, you want to compare this guess against the known closest to see if it's closer. So you carry the number up by 1, and then you say, if it is that this guess here is closer to the number of beans than it is against the known closest guess, then you assign the current guess to the closest guess, and you assign the current number to the closest number. Once all that is finished, right? So we do this until a value less than 0 is entered, right? Or value 0 or less is entered. Once we come out, we check to see, if there are valid entries. How do I know that there are valid entries? Well, this current number started off at, if the first number entered was a negative number, this would not get done, and this loop underscore n being equal to 0. If there are valid entries, right? Sorry, if there are no valid entries, then we print out a message saying that there are no valid guesses in the contest, right? If there are valid entries, then you print out the winner and their number. Anybody has any questions? Any comments? All right, let me call a name. Clement, what you say? You cool?
Yes, sir. Very cool, like a cucumber.
All right, Emily, how we feel about this?
Pretty good, sir.
Pretty good? Selena? Selena there? What about Seth?
I good, sir.
You good? Brandon? Any issue?
I good, sir.
You good? Okay. Good to know. All right, so was this that bad? This is kind of similar. This is kind of similar to what we have to do for question 8. It's similar in parts. Okay. You all want a little extension on the deadline?
Wow, sir. How generous of you.
Yes, sir. Yes, sir.
Yeah, that would be nice.
Yeah, that would be
very nice.
appreciated. Very much appreciated.
Okay. All right, because I feel like all of a sudden you all realize, wait, this thing is more work than I thought. All right. So the due date is now the 30th of November. All right.
Thank you very much, sir.
Okay. And you have a 1-day grace in terms of late submission. All right. And even though I still wanted to see if we could have got one programming assignment in, you know. So I am tempted to ask you all, just so that we have a bit of a programming, assignment in. I'm tempted to say if we could submit this as a programming assignment, this pseudocode, if you could convert it to a program. But I'll make up my mind on that a little later. All right?
Yeah, that sounds like a great idea, sir.
Yes, sir.
That sounds like a great idea.
Yes, sir.
Okay. Or maybe we could always just do the we could do the one that with the numbers, and if it's ready, same forward and backwards. Okay, but quicker we'll go with this one. All right, so yeah, I know I was supposed to give you all a break. Just take a 5 minutes to stretch your legs because we've gone an hour and a half straight. Take a 5 minutes to stretch your leg, and when we come back, well, I specifically wanted to address any issues you all had with the assignment today, so we did that. So we'll see if we could just I could just show you all the concept of nested looping today. Okay, just the concept, not too much with it. So 5 minutes, and then we'll be back.